Hello, today we're talking about finding missing angles on a straight line and around a point. So the first fact you need to know is that angles lying on a straight line always add up to 180 degrees. So in my diagram here, A plus B must come to 180. So if I get rid of the B and actually tell you how big that angle is, it's 35 degrees. We want to work out what size A must be. So all we have to do to work out A is do 180, take away 35, and that gives us 145 degrees. So A is 145 degrees. Sometimes the straight angle is split into more than two sections. So here we've got this angle that's 35 degrees, this angle that's 45 degrees, and we want to find the size of the missing angle B. Again, we need to use the fact that all of these angles on the straight line add up to 180 degrees. First of all, we'll add together 45 degrees and 35 degrees. That gives us 80 degrees. Then we'll just take that away from 180. So B must equal 100 degrees. Now here we've got a slightly different example because we haven't got a straight line. Here we're looking at angles around a point. And the main fact that you need to know here is that angles around a point always add up to 360 degrees. So here A plus B must equal 360. So if I tell you that A is actually 130 degrees, we can work out what B is just by doing 360, take away 130. That gives us 230, so B is 230 degrees. Here's another example of angles around a point. But here we've been given two angles and we've got to find the third angle, C. All we need to do is add together 120 and 110. That comes to 230. Then we need to take that away from 360 to find out what C is. 360 take away 230 equals 130. So our answer is C equals 130 degrees. Okay, so here's the last thing that you need to know for today. And that is that when you've got two straight lines crossing each other like this, the angles opposite each other are always equal. So here, these two angles marked B will always be the same, and these two angles marked A will always be the same as each other. These are called vertically opposite angles. Now this means that if we know just one of these angles, we can work out the sizes of all the others. So let's say that this angle has been marked as 40 degrees. That means we know straight away that this angle opposite it is also 40 degrees. Now the next thing that we can use is the fact that angles on a straight line always add up to 180 degrees. And these angles A and B are on a straight line, so they must add up to 180 degrees. So if A is 40 degrees, then B must be 180, take away 40, which gives 140 degrees. And if this B is 140 degrees, then this B must also be 140 degrees because they're vertically opposite. So now we know all the angles around this point. Let's do one more similar example. Here we can see that we've got one angle marked 110 degrees. We can tell straight away that D must also be 110 degrees because they're vertically opposite. So D equals 110. Then looking at D and E together, they must add up to 180 degrees because they're on a straight line. So E is 180, take away 110, which gives us 70 degrees. Now the other angle E is vertically opposite that, so that must also be 70 degrees. So now we know all our angles. So now it's time for you to have a go at a few. See if you can work out the sizes of the angles A, B, C and D. Remember that angles on a straight line add up to 180 degrees and angles around a point add up to 360 degrees. You might want to pause this for a few minutes whilst you work them out because the answers will appear in a few seconds. So there you go, there are the answers. Hope you got them right.